This is Josh Brinson. This is my game physics, Angry Birds code walkthrough, overview, demo, whatever in lieu of a write-up. The code word is Apple. I have my code open to azulcore.cpp right now. I actually did very little in this particular file because one of the first things I did was create an Angry Birds singleton that had the initialize, load content, draw, update functions all in there, and so I just hooked into them in here so that any additional code I needed in here I could write in my world and try to stay out of Azul's world as much as possible. I couldn't stay completely out. I had to add my screen dimension and world dimension variables, not only here but in like the sprite files. There were some changes in my camera code because I went with an orthographic camera, but most of my code is over in the Josh filter here, and I tried to stay out of Azul as much as possible. The only major exemption to that is input. Initially I was going to just hijack the keyboard test and mouse test code and put everything I needed in there, but I ended up wanting quite a bit more structure, so I created the input handler singleton. Process input is called during update. It gets the states of the mouse and keyboard, processes them, which basically means like checking the previous state against the current state and setting all of the appropriate booleans, and then applies it, which is where it does anything really. It goes through and checks to see, okay, what's going on with the input. If you've just pressed the left mouse, then you should try to grab the bird if one is available to be grabbed. That's where it checks to see if your mouse is at the right location. If you click the bird, or click the left mouse button, which means it was pressed and now is released, then it will launch the bird if applicable, or it will try to trigger the bird's ability if applicable. Otherwise, if you're just still holding the mouse, it'll update the bird's position, again if you've grabbed it. Right click does this little helper function which I used for a variety of testing, so I called it right click debug. You can see some old print statements here. Right now it just resets the bird. Generally this was anytime I needed to test something, I mapped it to right click, so that's why this function's at the top of the file. It changed a lot. Spacebar restarts the current level, and then move camera is where I deal with all of the camera control movements. And since I was doing that in here, which is really outside of the scope of the input handler, but that's where I put it. And because I put it in here, I ended up putting in the automatic movement of the camera as well, just to keep it in the same place, I guess. Ideally I would refactor this and create some sort of camera motion class or something, I don't know, that would actually deal with all this so that it wouldn't be polluting this file. But that's neither here nor there. So that's the only major exception, I believe, to code in Azul land. Everything else should be in the Josh filter. So my game object hierarchy is pretty much everything that's in game objects here. I inherit from manling to create game object, which is an abstract class, and it has some stuff that's very universal to game objects. Dynamic objects inherit from it, and static objects inherit from it. Static objects have another layer below them, static box, static triangle. The only reason to have more than one type of static object was because of the type of sprite used, but by the time I needed something other than a box object, I really wasn't using the debug sprites anymore, so all of my static objects are static box objects, whether they're boxes or not. Dynamic objects are a little more interesting. My birds, blocks, and pigs are all dynamic objects. Then this is what I have like as the generic dynamic object layer, I guess. Blocks, pigs, birds. Then from there you get your wood, glass, or stone block, your standard pig or your helmet pig, and your red bird, yellow bird, green bird, and so forth. Rope objects inherit directly from game object, and that was mostly because I wanted my rope objects to be handled by my game object manager, so they need to be game objects. But otherwise there's so much that they don't actually need that I probably, if I were redoing this, would make them kind of their own thing, or I would actually probably redo how my game object hierarchy works quite a bit. It was sort of, it grew by as needs came up rather than out of a master plan, and I would probably plan it out a little bit better now that I know what all the objects I need are. Come back to this later. My systems, I've got my contact listener. Initially I was doing, I think like everyone, all of my damage stuff in post solve, but I did not at all like the way that felt, and I tinkered around with this for way longer than I should have. I spent way too much time on it, but ultimately I came to the conclusion that doing my damage calculation in begin contact made the game feel much more, well, much better and much more like the actual Angry Birds. I no longer have the problem of my bottom layer of blocks crumbling under the weight of a tower, and that's because I only do damage calculations in begin contact, and because it's heavily based on the velocity of the collision. So blocks that are resting on each other or nearly resting on each other won't do nearly as much damage as a bird that collides into the block. I make the birds punch through blocks by, in pre-solve, I turn off, if an object is destroyed, then I disable the collision, and then I have an overkill ratio function that, where's my block objects? It returns the damage over 100, so if something is killed, then based on how much it's killed, you will you'll reduce your velocity, and so the more, so if you did 110 damage to something, it's destroyed, but only by a little, so you take a pretty significant velocity hit. If you destroyed it by 180, you really blasted that thing, so you lose much less velocity on your way through the block. And it seems to hold up in the game pretty well. I like the feel of it. The specific numbers need some tweaking still, but overall, the way that I'm doing these collisions in general seems like it's very much on the right track. I'm pretty happy with it. Contact listener, so the level class, there's not really much reason to spend time on. You've seen this demo already. Not that one. This is where all of my Lua code is at. So I begin the level and load the appropriate Lua script and then call my functions, and I'll just open a Lua script. But it grabs the data out of here, bird list, pig list, block list, and creates all of the appropriate objects. So again, you've seen that code. My game object manager is a little bit bloated, partly because I actually maintain several lists of different objects. The main reason for this was that initially I was using the list to keep track of like when you ran out of birds or when you ran out of pigs and the level needed to end. So I needed separate lists for each of those so that I knew that the end of the list meant no more birds. I ended up moving that to counter, and this structure just sort of lived on because it did. And so consequently the game object manager is a little wonky. In addition to just having the lists, it also keeps track of what the current active bird is, sets the launch position, it goes through and deletes all the lists whenever I need to clear the level at the end of the level. And it also has restore objects, which at the start of a level, several frames in, I will call restore objects and set the damage and velocity and rotation of everything to 0, so that when the level loads up, all the blocks aren't perfectly where they need to be, and the physics simulation shifts things around a bit. That jittering can go on for quite some time, but I basically stop it after a few frames, and it might continue to if things aren't totally settled, but generally after a few frames they're close enough that just telling everything to stop moving stops them from moving and they don't start moving again. Image map is a really weird system. It came from me wanting to not have all of my rectangle data everywhere. So this is how I map the image out of the texture file. This is where the red bird image is. I needed to have this every time I created a red bird, so instead of copy pasting this rectangle, I ended up just creating this so that I could just pass it red bird or image red bird and it would give me the appropriate rectangle. That way all this data only needs to exist one time. The need was somewhat reduced when I implemented the Lua level loading, because it just loops and calls the same line over and over instead of a separate line for every bird I need to create. But the structure was already there, so I kept it. It was a useful way of keeping all my data in one place, but again, it's just sort of a weird system. My object builder is how I create all of my objects. So in my level class, when I go to create birds, for instance, I call build bird object, and build bird object takes in parameters and constructs the bird. In addition to creating the game object, it calls build sprite and build box 2D dynamic, and then I have just code in here that controls what the properties of the bird are. This way, generally speaking, I'm able to just call create red bird and it's done. I don't need to do anything else. But of course I can still go in and access the body and change things if I needed one specific red bird or one specific stone block to act differently for some reason. My particle system is here. In my particle system, I think I already showed, I've got particle objects, explosion particles, and explosion sprite particles. These aren't very well named. The explosion sprite particle is the big boom explosion sprite that appears whenever something explodes. Explosion particles are the little particles that actually are the explosion that bounce off of things and push things around. And then regular particle objects are like the feathers and blocks that don't collide with anything. So the particle system knows how to create a particle, it knows how to create a particle body. It does basically all the builder stuff, but for particle objects. Create special particle was how I was creating the explosion sprite guy. So there's not, I guess, too much interesting. I guess the main thing is my particles have a lifespan that ticks down, and that's true of the explosion particles as well, although the explosion particles will also disappear if their velocity gets too low. My sound system, where's the H file? My sound system, I have pound defines for all of the different sounds that I might play at any moment. It's pretty simple. It's got start theme and stop theme, which I don't actually let do anything because the theme sound got incredibly annoying. Play sound once is the function I use, I guess, and it just takes in a sound name, which again is why I've got all these here, and plays it. Pretty simple system, really. Lastly, I will go back to my rope objects. My rope objects actually are sort of, so I've got rope link objects and rope objects. Rope object holds all of the rope link objects, which are the things that actually exist, the collidable stuff. I built this initially very simply, but expanded it so that you could pass it an array of positions and how many points you had, and it would create an arbitrary length rope that goes from your first position to your last, connecting through any other points along the way. And I'm out of time, so I won't actually be able to demo that. But that should be a pretty good overview of my code. Thank you.